Formula, it's just a little bit of high and a little bit of hard. Got a secret, so keep it on the low. If I tell you, make sure nobody knows. Because in my lab I got hits, in my lab I got rhymes, in my lab I got funk, in my lab conspiracists try to find out you get to the lab, but information won't leak cause I keeps it in the lab. Top security so thieves can't nab. No way to obtain, no way to have. You can't grab a hold of what's not possible. Why risk your life going through these obstacles? Don't even try to get it, don't even try to get it. A lot of people attempt it, but they gotta get it. And when they got it, didn't. Yo, the secret's hitting. That's just the way the song's written, bruh. I got a secret. Formula, it's got a little bit of high and a little bit of hard. I got a secret. Formula, it's a little bit of high and a little bit of hard. I got a secret. Formula, it's just a little bit of high and a little bit of hard. I got a secret, so keep it on the low. If I tell you, make sure nobody knows. Cause I know something that I can't tell. I know something that I can. Cause in my lab I got beat, in my lab I got heat, in my lab I got rhyme, in my lab I got funk, in my lab I got skills, in my lab I got rhythm, in my lab I got funk in my lab. Yeah, you can smell it way before you step in my lab. Make decks go deaf when I bump it in my lab. Huh? What? Talk about, huh? What you say? I got a secret. Formula, it's got a little bit of high and a little bit of hard. I got a secret. Formula, it's a little bit of high and a little bit of hard. I got a secret. Formula, it's just a little bit of high and a little bit of hard. I got a secret, so keep it on the low. If I tell you, make sure nobody knows.
Hi guys, welcome back, and I think you guys can see exactly where we are. Let me just make sure that that's turned off too. There we go. Very good. Alrighty, so let me go ahead and start off and say hello to DeCosted, Healdrick, Less Music, the Midnight Manufacturing Company, X-Ray Charlie, and Yeoman, and all of you beautiful lurkers who are watching us right now. Thank you very much for joining us tonight. So,
is that better with the light off?
Yeah, a little bit. Here, let me go ahead and
I don't think they can get the detail.
There you go. It's kind of difficult.
How about if I come in from this side?
Yeah, this is actually long enough. I actually got a long enough USB cable. There we go. Nice. There you go. Let me reposition it.
Okay, just remember it's hot.
Oh, I know. There you go.
You can see through the lamp.
I know. Just moving it back just a little bit.
Okay.
There we go. Dropping it down. Here we go, guys.
There you go. Oh yeah. Yeah, if you could just.
Perfect. Alrighty.
I don't think so. It just doesn't show it off right.
I know.
Dare I try to rotate the printer? Every time we do that, something gets unplugged.
I know. So, I know this is a little bit unorthodox that we use from what we usually do when we show you guys, but to be sure, we're here.
How about we talk to them and then we'll come back to this?
Yeah, it'll be just fine.
That'll give them a chance to
ask us questions.
Yeah. I don't know what's going on.
So
they got it.
Oh, I know.
Sure.
But I think it'd be nice just to show them, well, what we're printing. The fact that we are printing. So, okay, you ready?
Yeah, yeah, sure.
Alright, I'm going to go back over to the regular place, guys.
Okay. I will.
Alrighty. How you guys doing tonight? One more trick. Okay. And there we go. Oh, sorry guys. That's the one.
You know, if it weren't for Gorilla Tape, I don't know what we'd do.
I know. Excellent. So,
no one said anything after that.
I know.
I don't understand.
All right. Well, good night, guys.
Okay. Good evening.
Yes. Good
And
evening.
you know, all along, one of the things we've wanted to do is we have a QC procedure we're trying to follow, and the correct word there is develop.
Yes.
So we have one part that fits on the printer, and we said if the printer can't print it, the printer can't ship.
That's right.
And we've been trying to stick by that. And so it's a simple part, and it's a part that will go in the top. So maybe I should just go grab one of the stunt doubles. You got it?
I'll go
Okay. Hutch is going to go get a stunt. It's a real printer. Ooh.
Well, actually, you know what? We've got.
Nah, bring a printer in.
Okay.
These guys are going to want to see the real thing.
All right.
After this long of waiting, they're going to want to see the real thing.
No.
Here, you got one right on your desk. Just bring an engine. Yeah, because I can put it on the floor. You can do a top-down view of it that way.
It's just not.
Okay. Here comes the show off. Mind you what? I was going to put it right here. Oh, you want?
There we go. That we can roll it up a little closer.
Yeah, well. Okay, but all right. He's in charge, folks. I'm just sweeping the floor.
Try to get some good lighting. Okay. Here we go. Now. Go ahead.
So the
Okay.
subject of many heated discussions here at HYREL 3D is how to plug the hole in the top of the universe. And we have a design contest, and you can see that there is now a cover for it. So I guess they can see it. Let's see. Oh yeah, they can see it. And so let's test it. We've never tested before, and it hits. Ha! What is it hitting?
That's part of getting a 3D printer.
Oh, you know
Looks
what?
like this is the truck, isn't it?
It's hitting the magnet.
Oh. Because of the Hall effect sensor.
Well, the Hall effect sensor is where exactly where it belongs, but the magnet needs to go up a little bit.
Yep.
So we can probably do that. It's like 1/2 millimeter or so. Okay. So as you can tell, there's a reason why I haven't checked this. We just got this one hot off the press, and we're making another one over there. So you know what? We could probably print a new one of these, but it's the magnet. So we'll move the magnet up. We haven't had a cover before to check it with. It's a simple thing of pressing the magnet up the millimeter it's off. The Hall effect sensor still has plenty of range for it, so that should work fine.
Yep. So that's part of rapid prototyping, guys.
So what we'd like to do is just take a few moments and document for everybody what we went through to get this to print to our satisfaction. And we want to do that because the solution to printing had nothing to do with the printer.
No.
There have been, there's a large community out there of makers. I'm not saying we're makers. We kind of really are makers because that's what we do. But there's a large community of people that have been opened up their energies, their creativity to 3D printing, and they have freely shared information. And for that reason, we want to freely share the recipes that we've discovered from lots and lots of people and the keys to making something that's bigger than a postage stamp with relative ease, actually. But if you don't know these secrets, forget it. You might as well take up underwater basket weaving, because these things will peel up, they will distort, they will spring onto the floor while you're not watching, all kinds of things.
Yeah.
And so without too much further ado, we'll talk about the recipe. First things first. Food chain is you have to have something you're going to make. And so you CAD it up, and if possible, you can make radius corners. If you do that, you can do this at a little bit lower temperature. Now this is ABS we're talking about. It's not PLA, it's not plasticine, it's ABS.
Or PVA or anything.
I'm not going to say this applies to the other materials until we've verified and have a really solid recipe for it.
Yep.
With ABS, if you want sharp corners and you want an object that's fairly large and fairly tall, so that as you're building it, it has shrink stresses built into it because the plastic is cooling, you need to have a couple of things. Number one, you've got to have something that will hold it. And there are 50 different ways to hold it. We tried 57 of those. From my standpoint, there are a couple little genius tricks out there. And number one, comes from Greg and Hutchison. Their discoveries online is this magic sauce. Don't drink it.
No. And don't get it near an open flame.
It won't catch fire. Acetone's not a problem.
Oh, okay.
It's not a problem. They use it in hospitals for that very reason. That's a myth that you guys have got. It has an extremely high flash point.
Yeah.
So hot that you can extinguish cigarettes in it. So it's not your biggest hazard. Your beer will catch fire quicker than your acetone will. However, ventilation-wise, you know, you're going to be smelling a little bit of it, and that's not the perfect solution. Although, again, they use it in hospitals to remove glue from the surface of the skin when you have bandages and stuff like that. You don't want to do it. So it's fairly biological material. Check your MSDS to be sure that, and don't just assume you're not allergic to anything. So in this case, I would put a little drop and test it on your skin. Some people are extremely allergic to things and don't know it until it's too late. You know, I don't want you like swelling up the size of Pumpkinhead. But let me get back to what we do to printing.
If I can interject.
Yeah, go ahead.
One thing about this, guys, I just want to say thank you very much to Hackaday, hackaday.com. If you guys are out there watching, this particular recipe came from your site, and also from the Vision 3D guy who was out there. I watched your video. Thank you very, very much for also putting it out there and confirming what this stuff does. Which is, if anyone wants to Google it out there, it's ABS glue or ABS juice. It's all open source, and I think Hackaday posted the information in April this year. So have at it. There you go. Sorry. So just wanted to give credit back to
absolutely,
people
absolutely. These guys, without their guidance, we'd still be praying.
Yes.
Okay. So there are a couple things. One is you prime. We're talking about printing on glass.
Yes.
And actually, printing on glass is now a personal favorite for ABS and plasticine.
Yes.
So to get it to print on glass, you got to have an elevated temperature. Because if it's cold and it's ABS, I don't care who you are, you've got to be David Copperfield or Siegfried and Roy with 2 tigers to make it work. We are not Siegfried and Roy, and we have no tigers available. So you coat it with a Q-tip, and you just swab it back and forth over the surface till you can see a nice hazy surface. And this is the build area you're going to be printing on. Just dip it in. It takes 30 seconds to coat up a surface this big. It's no big deal. And you should know we're already see a way to automatically dispense it, and we're looking at our own tip that we can come in, dip, and paint it up for you.
Yes.
So that will be one of our future adventures. At the moment, it's not critical because any little paintbrush or one of those, the sponge brushes, although we're not so sure that the sponge brush won't be eaten by the acetone. So
what they usually say online is to use a paper towel, and you only have to wipe it down once, but that's not necessarily true for certain particular areas. If your humidity is quite a bit higher than the rest of the country, i.e. here in the south, you may have to put more than one coat on your build surface. So just be cognizant of that.
Yeah, there was another thing there, and that we are in the worst possible conditions for printing, in case anybody wants to know that. You might be printing on the North Pole because there's not much humidity there. But here we are having one of the wettest summers on record, and our humidity is at 192%, but close. We're very high. Florida might be 1% higher than us right now. We're sweating before we get out of the shower. So much humidity here. So that really hurts your build. If you want your material to stick, you need a low humidity, or you need the super secret sauce, which is just little pieces of ABS cut up and put into acetone. Do it in a glass jar. We used a mason jar knockoff, which we got from Hobby Lobby, for anybody who wants to know. And of course, that's not commercial, but don't worry about that because actually it's a nice glass container.
And make sure you get one that does not have the rubberized coating on the top, because the acetone will eat through that. Okay. And another thing is that please, whatever you do not put acetone in bottles like this because it will eat through it. All right, you've been warned.
High density polyethylene works great.
Yes.
And you can get those squeeze bottles. We're actually going to look and see if we can't get a bunch of them that we can source, so we can include them in a little kit for you guys. Yeah. Anyway, now that you've coated it, get your bed temperature up. and the bed temperature we're printing at right now says 83 degrees C.
Yeah.
And well, we'll check it in a little bit. You don't have to worry. There'll be a lot more views of this print, because unless it catches fire or it fails, it will print for the next 2.5 hours.
Yeah.
So what we wanted to do is just, show you guys where we're at and show you that we are printing big parts now with extreme satisfaction. The surface, I'm loving it. The squareness, the dimension fit, it's all great.
I wonder if I can get a nice little sheen in there. It's almost reflective in certain areas.
Yeah, you can see that surface
here
coming off the glass. The right-hand side, I actually did a post-process on.
Look at that.
The left-hand side, I did not. There you go. There you go.
So.
Okay. Now, one thing he didn't show you is.
Oh yes. The one little.
Well, that's okay. We were working late last night, but I want you to see how straight that turned out. I am not doing anything to this, and that's just like an arrow. And the little divot that you got, or the little dimple in there, that was an old man late at night who bumped into the table. But we continued the build, so it's not supposed to be there. You'll see it on the next part. Someone gave us high density polyethylene from Les Music, says at Granger for $4. I can get them probably for $4. Thank you, Les.
Yes.
All right, so we're at 83 degrees C is what it's saying. It means that our build surface is closer to 90. We have a thermal gun we're shooting it with. Our ITDs are lower on the thermistors are mounted on the bottom, and they're not on the top of the build surface. Now, have no fear, don't freak out. We're about to share with you that we were only able to get to the 75-80 degree mark. You need to get to 90 degrees C at the build surface.
Yeah. For ABS.
For ABS, and this humidity, with this recipe, working on glass. And what we're, our whole goal has been, and as I communicate with Greg, I tell him I want to uncross my fingers when I press the print button.
Yes.
I want to know that it's going to print, and that it has to be like a power failure is the reason why it doesn't print. It's not because that we didn't sacrifice enough chickens that day or something like that, because that's what it feels. Well, it doesn't feel like that now. Now it feels, so far everything is printing each and every time. The head is dispensing each and every time. We have a couple little tweaks that we're going to do tomorrow and the next day to make it even more beautiful and even more consistent. Although right now it's fine. I mean, I feel like we've got a great finish so far. Someone just asked us, Yeoman, how long it took to do this print. This print right here was says 2 hours and 30 some odd minutes, but I think it was closer to 3 hours.
We started around 9, almost 10 o'clock, and we finished up right around 12:30.
Well, so he finished up. I went to bed.
I know. I know. So
the layer thickness on this one is 0.3. It's 300 microns, 0.3 millimeters. Now, this is not the fastest print.
Yes.
So here's our food chain. Quality first, speed second. Now I can tell you right now that the slicer betrayed us. Inside some of these areas are the most bizarre little tiny half-millimeter zigzags in here, and we're looking at each other going, how can this be? Because it's a straight line, and then they do a zigzag to fill in where the straight line is, and we're like, this doesn't make any sense. Don't worry, we'll figure out those settings, and we will filter those out ourselves if we need to by removing moves that are under a certain distance. We can easily calculate that out. So I just want you guys to know, if for us, as we've always said before, we can double the speed by just turning on a second head. So in this case, I could easily print 2 of these at the same time, easily.
True.
And that's actually going to be a lot of fun, except for I only need 1 per printer. That said, quality of print first, speed second, and you will see us continue to grow in the speed, and most of that will be software oriented. it doesn't care too much about how fast we're moving. As far within realm, we could go up 150, almost 200% of what we're printing out right now. You have to understand that when slicer gives a little zigzag pattern like this, then our problem is that it starts to shake the printer violently because the printer's doing what it's told to do.
Yep.
And there's no reason for these short, fast, jerky 1 millimeter moves that they're not really filling in something.
They're not there.
So we have to go through and put a filter on it because those particular moves are very unfriendly towards rapid movement. We'll figure that part out. Don't worry, that's in the software realm. Those things will be obviously available to you guys ad infinitum forever, and we'll look forward to improving that part of the software.
Guys, I gotta say, when I was up last night watching those particular quick little moves happen, I can understand why. I mean, obviously I understand why ours did not shake apart, but I can definitely see why other 3D printers would shake themselves apart.
Some kits, or some people from Bits from Bytes printers, we could see where those that were not securely fastened with Loctite and lock washers and metal-to-metal joints, because any plastic joint, you're just going to eat it alive after a short period of time.
Yeah.
So it's interesting, because this is a part we hadn't really delved into so far.
And the speed wasn't that fast.
No, our speed was down. We're moving only just under an inch a second. So we're not like Greg's got a Delta bot he's testing right now, and he's telling us he's going 3-4 inches a second. So I would love to see it try and do this particular move at 4 inches a second. I don't think it's possible.
It wouldn't be good for the machine. So yeah.
The build platform came off. Well, I'm sorry about that.
The cost had said that's a problem I have all the time with my current printers. The build platform on my Up Plus came off once because the adjustment screws backed out. See, and hence the reason why we need to what we're doing and what we're looking into when it comes to the slicer as of right now.
Yeah,
because the vibration, exactly the cost. You're absolutely correct, because it will shake itself apart.
We already have people looking at the slicing, but I am personally not involved in it at the moment. We will delve into it shortly. I already seen the algorithm that this thing is pulling off from Slicer 3. And please don't misinterpret me. They did it. I mean, Slicer 3 and Skyforge, they all did it. The rest of us are sitting around playing Parcheesi. They did it. So I'm not saying they aren't great and didn't do something. I'm just saying that these particular things are weak points that we need to address if we're going to move to the next level of reliability and quality of print. So again, our food chain's simple. Make it beautiful, then increase the speed. And the easiest way to increase the speed is to control the motion. And the easiest way to control the motion isn't to do a bunch of small jerky moves when a sinusoidal. See, if I was going to do a fill pattern, I wouldn't do bonk, 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 bonk. I would do a sinusoidal, so you have constant velocity change. And now it's going to be, oh yeah, this is fun. Not, oh, ah, ooh, ah, ooh, ah. You get what I'm saying. If you own a printer, you'll know exactly what I'm talking about.
Nice and jerky versus,
so, hopefully that was a good explanation, and don't ask me to do it twice in the same night. Okay, so for just a second now, we're going to put the camera back over, because I'm sure you guys think that was a stunt double, and it's really not even printing. And we're going to go back over and see how it's coming out. And I can't see from here, so it might be terrible. If it is, bear with us.
All right. And you'll have to bear with me a little bit as well, guys, because it's cable city over here. All right, here we go.
Oh, with your permission, Master.
Yes. Hold on. Make sure it doesn't pull itself apart. Okay, there you go.
I sure hope it's focusing.
Oh yeah, oh, beautiful. Oh yeah.
So I think you guys can get a load of the consistency of the build and how straight the lines are. See if I can get it to focus. There, it just focused. And so far, so good.
Picasso said that looks really good. All right, thank you.
Let's get down on my favorite angle, because this is the one that I always reveal at. It's what we call the, who are those guys that landed the airplane short angle?
What?
You know what? SFO?
Oh, that would be Asiana.
Yeah, this is the Asiana San Francisco flight view. Look out, the runway's hitting us.
Nice and flat. Oh yeah. Yeoman asks, is the lamp part of the secret?
Yes, but we can't tell you all that.
If we tell you, we have to kill you.
Alright, so I guess they got a little look at it. It's fun to watch that thing running.
Oh yeah.
No one wants to see it print again.
Well, they got a little bit of a taste last night. I edited a video, and what you don't know is I put that on Kickstarter, so they saw
Sweet.
the part being made a little bit.
There you go. Okay.
So, hopefully you guys like that. So, because I'm going to be making a lot more videos, printing videos like that. So, some of you guys know this, who've Skyped in with us. And, we're dropping a few frames. Sorry about that, guys. I don't understand why, but that's okay.
Alright, someone noticed that we were using a heat lamp.
Yeah.
Darn it. We were going to put that in the box and surprise everyone. Now, all seriousness aside, we couldn't achieve the temperature that we wanted to achieve under the current hot tables configuration. So the first thing I did was I put in some thermal blocking slots in the back, and that raised us 7 degrees C. We turned off the ceiling fan, and that raised us 7 more degrees C. And got us close enough to where the print was starting to look good. And we realized we need to be able to achieve 100 degrees C in a non-ventilated room, meaning a room that's not got a big fan running in it.
And that's 100 degrees C on the heated bed platform.
Yeah. So we have a large flat area, and we did some checking. We've checked it with other hotbeds that are out there. We know we're at 120 watts. We have a boost circuit capability, but really that's kind of a mistake to just pour more power into it. The reason why it's a mistake is we're dissipating heat, and the right thing to do would be to insulate everything but the build surface so that our heat loss is baking the part, which helps it relax. Now my protege, my partner, the master of the universe, came up with a good point today. Yeah. He said, what's the glass transition temperature of ABS? And lo and behold, it's approximately 108 degrees C. So if you build just below that, you will hold your form reliably. When you go above it, you start to get a little droopy action. It might be slow flow, but it's still a glass transition temperature. So what you really want is to hold it between 90 C and 100 C. You don't want to go over 100 C, you don't want to go under 90 C. And that's what we're looking for.
The typical temperature that ABS, this material, is rated for is between minus 20 degrees C to 80 degrees C, according to Wikipedia. Now, that's where I got the information from. So, but it was a question that popped in the side of my head.
All right, we just got a great question from DeCosted. He's asking about the temperature gradient on the heated build platform. In the actual build space, it's plus or minus 5 degrees. So it's not so bad. We could improve on that if I want to throw some copper into this, and we will probably look at a hybrid build platform. I'm sure we will, but not within the scope of today. Now that we know we can print, and I can get this to reliably get us the 90 degrees C that we're looking for in a non-circulating fan. See, we all have ceiling fans in the south. There's one right above me here. Well, quite often at night you guys are watching it go whoop, whoop, whoop over our heads. But if you put a ceiling fan on, you're gonna really create yourself a lot of problems. We have someone that has an up printer and loves it, but also says that if you blow on the print, you ruin the print. And he says in some cases, if you breathe on the print, you ruin the print.
Yes.
So now that we're getting this experience, and now that we're starting to understand this, we're seeing that there are people that bought engines, and we think they're going to do well enough with them, but these will be some restrictions. You cannot put it in a highly ventilated